Imagine that you're planning a party and you want to make loop bags, and you want each loop bag to contain two items, one marble and one video game. You happen to have three different types of marbles, red marbles, green marbles, and blue marbles, and two video games, Super Smash Bros., very fun game, and Halo 4, also a very fun game. How many different loop bags can you make? So here we have our three marbles. If a loop bag contains the red marble, then that loop bag can also contain either Super Smash Bros. Or Halo 4. Notice that each path, each line segment represents a loop bag. So we can have one loop bag that contains a red marble along with Super Smash Bros. And the second loop bag that contains a red marble with Halo 4. Similarly, if a loop bag contains a green marble, that loop bag can also contain either Super Smash Bros. Or it can contain Halo 4. And similarly, if a loop bag contains a blue marble, that loop bag can contain a Super Smash Bros. Or that loop bag can contain Halo 4. So the total number of loop bags that we form is equal to the total number of paths that we have here. So we have 6 paths, which means that there are 6 different ways we can make loop bags. So this is a neat way to solve this question. We use a graphic visualizer, we can say it, a graphic visualizer. But let's say that we don't want to use graphic visualizers, we only want to do math, nothing but math. There is another way to solve this, and that's by using algebra. So there are 3 marbles, and each marble can be linked with 2 video games. So each marble has an option of 2 video games. And since there are 3 marbles, then that means we have a total of 6 video games. For example, red can be linked with Super Smash Bros. And Halo 4. Green can also be linked with Super Smash Bros. And Halo 4. Blue can also be linked with Super Smash Bros. And Halo 4. So essentially we're adding 2 plus 2 plus 2, which is 3 times 2, for a total of 6 ways to solve to make these loop bags. And this algebra method of multiplication is very similar to the fundamental counting principle. So let me bring this up. The fundamental counting principle states that if there are m ways that event 1 can happen, and there are n ways that event 2 can happen, such that event 2 is independent from event 1, which just means that event 2 occurs regardless of how event 1 occurs, then there are a total of m times n ways both events can happen simultaneously. In our example, event 1 was marbles. How many ways could we have chosen marbles? 3 ways. Event 2 were video games. How many options of video games could we choose? We had 2 options. Then that means there are m times n, 3 times 2 ways, both events. Choosing a marble and a game can happen simultaneously. In other words, to choose a marble and a game is to make a loop bag. Therefore, there are 3 times 2 equals 6 ways to make a loop bag. And this is the fundamental counting principle. If there are a certain number of ways one event can happen and a certain number of ways a second event can happen, such that the second event does not affect the first event, then there should be the product of the number of ways each event can happen as the number of ways that both events can happen simultaneously. So fundamental counting principle deals with 2 events, but we can expand this to a third event. Let's say there are k ways event 3 can happen. K ways event 3 can happen. How many ways do you think can event 1 and event 2 and event 3 happen simultaneously? You probably think it is for a total of m times n times k ways, and that is correct. The reasoning behind this is that we can treat event 1 times event 2 as one event. So this becomes the new event 1. Or let's not say event 1 because that's a bit confusing. Let's just call this event alpha. So there are m times n ways that event alpha can happen. Let's call this event 3. Yes, this is event 3. And there are k ways event 3 can happen. So by our fundamental counting principle, we have technically 2 events, alpha and event 3, which means that there must be the product of these two n times n, m times n times k ways that both events can happen simultaneously. And this is really cool. We can do multiple events with the fundamental counting principle because the fundamental counting principle acts recursively. So the first two events now act as one event, and we multiply that with the third event. So let's say there were x ways that event 4 can happen. Then how many ways can all 4 events happen simultaneously? M times n times k times x. Very interesting. And this is the fundamental counting principle. Thank you for watching.